Hi, Shreyas.
Hello, sir. How are you, sir?
Good in yourself.
I'm fine, sir.
Great. Is everything clear? Are you able to see on the screen?
Yes, sir.
Okay, 100%. So, for today's lesson, obviously, as you proposed, we'll be looking at those type of problems. Is it because are you writing a test anytime soon, or are you on that chapter at the moment in class?
Yes, sir. I'm writing a test on it.
Oh, okay. All right. Now I see. So we'll just skip everything else that we're to do and jump on that one. So maybe at a later stage, we can still go back to where we're supposed to be in terms of our program. But before I start with showing you those examples that you send me on via inbox, I just want to quickly teach you something which is called algebraic functions. So if you refer to that study guide that I sent to you, everything that I'll be talking about is on page 13, but I'm going to quickly summarize it for you in this lesson. So you can just quickly go to what is it, page, it should be page 13, which is unit number 4. So it's algebraic fractions. So obviously in this case we are simplifying fractions. You remember when you simplify, it means you've got what is it? You've got an expression, isn't it? So
Yes,
obviously, in this case, we'll also be looking at given expressions. Let me just quickly try to check if I can unmute. Let me see. Cele, are you able to unmute your mic and speak? Because I don't think I've allowed. Let me see. Mute. Mr. Cele, are you able to unmute your mic and make a comment?
Yes, I'm able to.
Okay, all right. Now then that's fine. I'll continue. So let's see. So I want to quickly talk about what we call special fractions, and again talk about negative fractions. So this is in preparation to what you sent via inbox here. So I want you to notice something. A over 1. This is the same as what, Shreyas?
0.
Okay, let's see. So this is letter A, ne? Which is over
Yes, sir.
1. So let me write this. You can just write it as part of your notes. Anything divided by 1, it's equals to anything. Write this as part of your notes somewhere, Shreyas. Anything divided by 1, it's equals to anything. Anything could be a letter, which is any letter from A up to Z. For as long as you divide by 1, it's that letter. So anything includes any negative number, and again a positive number. For as long as you divide it by 1, is the same as that number. I'm just going to quickly confirm about 0. So if you want to confirm that one, you will need to say 0 divided by 1 and see if you get 0. Then you still get 0. So when I say anything divided by 1, it means whatever that you have as your numerator, when you divide it by 1, is that same number or letter. So, Shreyas, in this case, what are we having as our numerator?
Zero.
Let me expand. Let me see who's also on the line. Cele, Liad. Mr. Cele, do you know the difference between numerator and denominator?
Yes, sir.
Okay, there I've got my over. Where do I write my numerator? Where do I write my denominator?
The denominator goes at the bottom and the numerator goes at the top.
Okay, all right. A numerator, then denominator. So, Shreyas, so you can also
Yes, sir.
add this one as part of your notes somewhere. So, let's say, for instance, you have 2 divided by 3. Ne? So the number which is written at the top of that line is called a numerator. Ne? And then a number which is written at the bottom is called denominator. So when we have a divided by 1, can you guess which one is the numerator and which one is the denominator?
Numerator is A, denominator is 1.
100%. So, according to what I've written here, where I say anything divided by 1, what is the numerator and what is the denominator?
So you can write any number divided by the denominator, which is 1, which will give you any number.
So, between anything and 1, which one is a numerator and which one is a denominator?
So the numerator is anything and the denominator is 1.
100%. So according to this, it means anything divided by 1 is equals to anything. So according to this, you set A's numerator over 1. So what is A divided by 1?
So can you please repeat, sir?
So you agree A is the numerator, isn't it?
Yes, sir.
Which is in that position of numerator, which is in that position of anything. So you said denominator is 1, which is that one over there. So now that we've got A as numerator and 1 as denominator, what is A divided by 1 according to all of this information?
So the A can be any number and the denominator will be 1. So, sir, if we say A will equal to 0, it will give us 0. A is equal. Yes, sir?
Yeah, no. I wanted to, maybe let me understand, how do you get that 0?
So I'm not sure, sir.
Okay, so remember, you know there's that 1 over there, isn't it?
Yes, sir.
So a number at the bottom divides a number at the top. I'll give you an example. If you have let's say 8x divided by 4. Can you guess what is that one?
The 1 would be the invisible one next to the x.
So, or maybe you can guess what do I write there?
So it will be 8 bracketed brackets.
Or then I see I'm running out of space. Let me say 8x is equals to 8 into
1 close brackets over 4.
1 close bracket, then
over 4.
All over 4 like that, ne?
Yes.
Okay. So, Shreyas, based on your response on these questions, it means we have skipped what we had to do first before we get to what you proposed for today's lesson, because this is something that you first need to know and understand before we can get to today's lesson. So remember, 8 divided by 4 is how much?
8 divided by 4 is 2.
Is 2. Then it means you've got 2x. So that means this is the same as 2x. So what is 1 divided by 1?
So it's 1.
Which means it's 1a, which is the same as a. So let me see. Okay, no.
So say if I take so any number, so like say 4x over 2, you have to say that 4 divided by 2, which will give
4a divided by 2. And okay,
2x. Am I right, sir?
Wait, let me remove all of this because the line was breaking a bit. You can just repeat that example. It was a good example. I wanted to write it down and explain using that one. So you said...
So if I say, sir, 4x over 2.
Mm-hmm.
So, sir, then to get your x, then you have to take your 4 divided by 2, which will give you 2x.
Yes, but in that way, we are not solving because this is not an equation. It's an expression. So you simplify. Yes, you simplify, which means it's 4 divided by 2, which is what? Which is 2. X remains as x because a number, you cannot say letter divided by a number. It's always a number divided by a number, which gives you 2 in this case. Then the x stays as x. But Shreyas, based on that anything over 1 is equals to anything, that's if you had 4x divided by 1. When you simplify that, it's because you have 4 divided by 1, which is 4, and then x remains. So can you see that top is that anything divided by that bottom, which is denominator, which is 1. So this is equals to anything. I'm not sure if it makes sense now.
No, sir, it makes sense now.
It makes sense, ne? So now you understand, okay, just to confirm, what is b divided by 1?
So b would be 1.
Or maybe tell me what to write there.
So since there's an invisible 1 by the in front of the b, so it will be 1 over 1, which will give me 1. 1b, which is equal to b.
1b, which is equals to b. So this is how you simplify that one. So remember, in this case, we are not solving anything. We are just simplifying. So this is the first thing that you need to be aware of, that a divided by 1 is equals to a. Then from there, when it comes to 1 divided by a, this is the same as 1 divided by a. It doesn't change this one, Shreyas. It doesn't change. So remember, still we've got that invisible 1 over there. We've got that invisible 1 over there. So it's more like you're saying 1 divided by 1a, which is still that 1 over a over there. Let me maybe think of a different, let's say 2 over 4y. What will that be? So you just ask yourself, what is 2 over 4?
So 2 over 4 would be half, sir.
It will be 1 over 2, ne?
Yes, sir.
So you just write 1 over 2. And can you see why it remains at the bottom? Because from that expression, it was at the bottom. So I think you've got an idea now. So let's now move to the other part.
Yes, sir.
And then now, what will be a divided by a? What will this one be?
So since both of the a's have an invisible 1, it'll still be 1 over 1, which will give me 1. 1a, which will be a.
So say 1a, which will be a.
Yes, sir.
So let's have a look. If you can check, that expression is not the same as that expression over there, which means it won't be possible to get the same value. So I'm going to explain to you that one. You remember, Shreyas, there was this, I'm not sure if I send it to you. I think I've sent it to you where I said it's a lesson where I teach the maths basic rules. I'll just check that one. So remember to watch that lesson from the start until the end. I will still teach you those maths basic rules. But if you can firstly watch that lesson until the end, you'll have an idea of what is going on. So, Cele, we've got 1 over there and 1 over there, as Shreyas has mentioned. So, with that expression, this is the same as 1 over 1, which is 1. So the letters, they cancel out. So you just remain with 1. So there's a rule which says a to the exponent, let's say m, over a to the exponent n. Because you are dividing that a to the exponent m with a to the exponent n, the bases are the same. If the bases are the same, you subtract the exponents. So that means you've got a and you've got that at the top, you minus that n at the bottom. So this is the same thing. Remember, when you have, let's say, a multiplied by a, let's say a to the exponent m, a to the exponent n. The difference in this case is that here you are saying a times a, or a to the power m times a to the power m. In this case, you add the exponents. So you can see there's a difference between these two cases where when you multiply the same basis, you add the exponents. But when you divide the same basis, you subtract the exponents. So if I had to use a number, it's more like, let's say you had y to the exponent 4 over y squared. So that means because you are dividing the same basis, you can just write that one base to the exponent 4, then you minus 2 over there, which is the same as y to the power 2. So that is what this rule means. So for this one, it's more like you've got, let's say, p to the exponent 7 multiplied by just p. You know there's an invisible 1 over there, so this is the same as p to the exponent 7, then you add 1, which is equals to p to the exponent 8. So guys, that part that I've explained, does it make sense?
Yes, sir.
Okay, so let me remove all of this, but I want you guys to understand, to fully understand this one, to say when you have p divided by p, guys, how can we apply that rule? Let me just write those two rules down there to say let's say a to the exponent m multiplied by a to the exponent n. This is equals to a is the same base. Let me just write it nicely over there and say this is going to be a to the exponent m plus n. Then if you have a to the exponent m divided by a to the exponent n, then in this case you subtract the exponents. So let's say this is rule number, no, let me use a number and say this is rule number 1, this is rule number 2, just so that when I ask a question I can say rule number 1 or 2. So according to this problem, which rule can we apply between rule 1 and 2?
So rule 2.
Rule number 2. So which means there's an invisible 1 there, there's an invisible 1 there. We agree on that one, which means it's 1 times p, it's 1 times p. Do we agree?
Yes, sir.
So that means 1 divided by 1 is 1, isn't it?
Yes, sir.
Multiplied by, then we've got invisible 1 there, we've got invisible 1 there. So that is why we write that p, which is a common base. Then we say 1 minus 1. So what is 1 minus 1?
0.
It's 0, which means we've got 1 multiplied by a p to the exponent 0. So Shreyas, again, anything to the power 0 is equals to 1. Make a note of this one as well. Just like you did with anything divided by 1, it's that anything. So when I say anything to the power 0, that means x to the power 0 is equals to 1. Y to the exponent 0 is equals to 1, which means any letter from A up to Z to the power 0 is equals to 1. Do you guys understand that part?
Yes, sir.
So let's continue from this one. What is 1 multiplied by p to the exponent 0? What is p to the exponent 0?
1.
It's 1. So what is 1 multiplied by 1?
1.
It's equals to 1. So can you see the reason why a divided by a is equals to 1?
Yes, sir.
So it's the same principle. It's 1 multiplied by a to the exponent 1 minus 1, which is equals to, you know, this is 0, then it's 1 multiplied by 1, which is equals to 1. So it doesn't matter whether there is B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z. So that means there it could be any letter, but you know any letter divided by, to the power 0, it's 1. So all of that makes sense, isn't it?
Yes, sir.
Cele, are you following there? Are we not losing you?
Yes, sir, I'm following.
Okay. So a to the power n. Okay, let's see. What else did I want to cover? I think I wanted to cover also this one to say 0 divided by a is equals to a 0, which means make a note of this one as well. 0 divided by let me be careful of that one. Let me check something first. 0 divided by 0, it's equals to error. Okay, so I think 0 divided by 0 divided by anything. Yeah, let me say anything except, in brackets, except 0. It's equals to 0. Guys, I'm not sure if that part makes sense. So it's more like if you have 0 divided by 2, this is equals to 0. If you have 0 divided by any letter from A up to Z, this is equals to 0. If you have 0 divided by anything, guys, except 0 divided by 0, then it's 0. I'm not sure if it's making sense, guys. Is it not confusing you, this explanation?
No, sir.
Okay, 100%. So that means you now understand why 0 divided by a is equals to 0. So the last part that I wanted to touch is that what is it? A divided by 0 is undefined. It's undefined. You obviously get 0. You get error when you punch that. So this basically means anything divided by 0 is error. Guys, does it make sense? You can test using any number to say maybe 5 divided by 0. It's an error. I'm not sure if you understand that part, guys.
No, sir, I understand it.
100%. So that's all that I wanted us to discuss with regards to special fractions. You will notice the importance of us learning all of this when we deal with the math problems. And again, we've got negative fractions. So let's check. Under negative fractions, let's say we've got negative a divided by b. So guys, can you see that negative? Remember, a negative can be there followed by that over there, where you've got a over b. So that negative, is it for a or is it for b, or is it for both?
So it's for both.
So does it mean this is still the same as that?
No, sir.
So does it mean this over that is the same as that?
No, sir.
So so that means this can only be written in that way, Shreyas.
Yes, sir.
Let me check. Cele, also try to guess so that when I explain, I know if we are all still together.
Yes, sir.
So my question is, we've got negative over A over B. So my question is, this thing is the same as that, and again, is this thing the same as that one?
No, sir.
So you are also saying it's not the same, ne?
Yes, it's not the same, sir.
Okay, so I'm going to teach you on how to test it. I hope all of you have got a calculator which has a fraction button. So on your calculator, say negative, then do that fraction button. Substitute 4 over there, and again substitute 2 over there. And punch again a negative 4 over 2. Punch again a 4 over negative 2. Check if you get different answers. If you don't get different answers, then it means this is just the same thing, which is the opposite of what both of you said. So just punch until you get to that one and let me know.
We got this, sir.
Same. So they all three negative fractions equal to negative 2.
So that means negative A. Remember, guys, these things, if you want to test them, A represents a number, and then if it's B, it represents a different number from A. If it's A, then it means it's the same number. It doesn't matter which number it is. So that means this is the same as negative A divided by B, which is still the same as A divided by negative B. So it's more like I'm teaching you guys the rules, or one of the basic rules that you need to be aware of, so that when we proceed to the actual problems, you fully understand how to operate those basics. So let me quickly check the other negative fraction that I wanted us to discuss. It's when you've got, let's say, when you've got negative A divided by negative, negative B divided by negative B. So do you have an idea of what is that one? So we've got a negative A divided by negative B. So this one, guys, it's actually the same as just A over B. Why? Because that negative, it just cancels. So, or otherwise, it's more like you say negative 1 divided by negative 1. So this is being multiplied by A multiplied by B. So you know negative 1 divided by negative 1 is the same as just 1 over just 1B. So guys, that part, I hope it makes sense, unless if you need me to explain it differently. I'm not sure if it makes sense, guys.
No, sir, it does make sense.
It does. So the answer would be a positive answer.
Yes, because you're dividing a negative and a negative, so you get a positive.
Yes, sir.
And the last one, let's check this one, is negative A divided by B. Is this the same as negative A divided by negative B? Is it the same? Shreyas?
Yes, sir.
Is it the same?
So I'm checking it out, sir.
Okay. Do the same, Cele.
No, sir.
It's not the same.
So it's both of you who are saying it's not the same, eh?
Yes, sir.
Yes.
I'm glad you've got an idea before you answer this question. You know how to check if it's the same or not. So this is where you put in that cross to say it's not the same. Nah.
Yes, sir.
100%. So guys, remember, I think this lesson will I'm going to post it so that if you need to refer to this notes, you can just go back to today's lesson. So I'm just going to remove all of this. Then from there, we'll try to do one type or two types of problems whereby I think maybe in tomorrow's lesson we can go deep into solving more of those. So for example, which is given there in the textbook, we've got x squared minus 4, all of this divided by x minus 2. You are given this thing to simplify. So they say simplify a fraction. So guys, this is an instruction where they say simplify a fraction. Shreyas.
Yes, sir.
Wait, I want to check which question I ask to fraction, an expression. Cele, how do you notice a fraction?
A fraction.
Yes.
It has to be like a certain number over a certain number.
Okay, which means for us to notice a fraction, we should be able to identify the numerator and a denominator. Ne?
Yes, sir.
So, Shreyas, now that we notice this is a fraction, what do we do when we've got this type of a fraction? By that I mean, do we solve or do we simplify?
So we simplify.
Why?
So we have to find the unknown.
So for now, I'm going to answer this question of why. So remember, when you simplify, you in answering the question of why, you can say we simplify because it's an expression. So otherwise you can say when we simplify, we are trying to write the whole of this in its simplest form. I'm not sure if you'll be able to answer this question when I ask it next time. Does it make sense?
Yes, sir.
100%. So guys, before you can think of going further with this type of problems, you firstly need to be confident with factorization. I'm going to emphasize this one, Shreyas, because on those type of problems that you sent to me, there's nothing much that you do other than simplifying. So if you want to master this chapter and also be able to easily solve or simplify those type of problems, you need to be 100% and confident again in factorization. Similarly, as when I wanted you guys to spend more time on solving for the unknown, or otherwise on solving for x. So Shreyas, you can still, let's say, be in class. Let's say you can be 5 ahead, 5 more lessons ahead of our program. But if you are not yet confident with the basics, you will still struggle. So, Cele, what I mean by that is that if we can make sure to strengthen our foundation, even when we get to the top and you find that maybe our roofing is a bit shaky, we know that we don't need to worry about what's being buried, which is our function, our foundation. But if we have a shaky foundation and we build on top of it, when we get to roof level and that roof is shaky, then we are no longer sure whether our foundation is solid enough to carry that load. So you'll find that we'll need to start over and demolish the entire building and again take out the foundation. So the foundations, guys, is those maths basic rules, it's factorization, it's a solving for the unknown. So these three, ladies and gentlemen, and there might be some more, which includes knowing those maths basic rules. So if you can master all of these, guys, I'm telling you, when we get to either a sequencing series or series, what is it? What are other chapters? You know, those chapters, analytical geometry or whatever. Whichever chapter that we get to, ladies, gents, I can promise you, you will never struggle, guys. So, okay, so now let me show you how you simplify this one. So now we need to be able to factorize this thing, guys. Let me firstly write down the rules of simplifying a fraction. So normally your first step is to factorize the expression in the numerator and denominator. So let me say factorize the numerator and denominator. And then your last step, guys, is to cancel the common terms, or cancel the terms common to both. Let me say, in short, cancel common terms to both a numerator and denominator. So, guys, do you understand that number one and number two? Does it make sense, or think it will make sense when we solve this problem? Does it make sense with what I've just said without applying those two?
Yes, sir.
Okay, 100%. So that means we firstly need to separately factorize the numerator and the denominator. Remember, it does not mean both of numerator and denominator can possibly be factorized. You might find that a numerator can be factorized, but a denominator cannot be factorized. So let's see. I'm not sure if you guys can be able to factorize this thing.
So wouldn't you have to break it down first?
Okay, give it a try. Give it a try. Let's see.
You'll just have to say x brackets first. Minus.
Oh, like that.
Yes.
Okay.
And then on the other side, you'll say x plus. And then you'll put 2 and 2.
Then why are you saying a minus and a plus? So otherwise, even if you said plus, minus, what?
Because any number, like for example, if you say 2 times 2 with a positive, if they are both positive, it'll give you a positive 4. But now it's a negative 4, so negative 2 times a positive 2 will give you a negative 4.
Okay. So Okay, no, understand. Shreyas, let me
Yes, sir.
see. Do you agree? Do you agree with your fellow learner there?
Not really, sir.
You can give it a try as well.
So it will be brackets
Mm-hmm.
x
Mm-hmm.
and x plus 2.
Plus 2 there.
Yes, sir. And then in the second bracket, it will be
Okay.
x minus 2.
Mm-hmm. Minus 2. Wait.
Yes, sir.
Cele, what did you have?
I said it was
It
the
was
same thing,
x, I
but
know 2x.
yes, it was
Oh,
just
you had your
minus at the
minus this
front.
side,
Yeah,
ne?
yes, it's the
Oh,
same
okay,
thing, sir.
So,
all right.
so with
Eh, eh,
so, so with Cele's one, sir, it'll if you
mhm.
put negative 2 plus 2, so it'll give you 0.
Okay. Let's check something, Shreyas. Remember, do you agree that 2 multiplied by 4 is the same as 4 multiplied by 2? Do you agree?
Yes, sir.
Which means if 2 plus if x plus 2, this is 2, and if x minus 2, this is 4, then it means in this case we are just swapping the same thing, whereby this is now 4 and this is 2, which means is the same thing, Shreyas. We'll just prove it. Let's see. When you
Oh,
say that times that, can you see now?
yes, sir. Now I can see it, sir.
All right, 100%. So now that we are all in agreement, so
So I just made a
I'm
mistake
very
here, sir.
much happy that. Say again, who was it? Was it you, Shreyas, who made a comment
Yes, sir.
just now?
Yes, sir.
Okay. So I was saying I'm very much happy that the both of you were able to factorize this, even though at first we had different thoughts on that. So let's see, we've got a bracket and a bracket, we've got a bracket and a bracket, we've got x, where it's either it's plus or it's a minus, then we've got that. So the other thing, let me see, maybe let's just discuss this one, guys. Isn't it like that to say you can firstly, maybe let's say it's not 4 there and it's a bigger number. Is it not that you check if it's a perfect square, such that you know you've got 2 squared, or maybe you've got whatever number squared. Let's say it was 16 over there. I'm just not sure of how to explain this one, but what I'm trying to say is, if I was given this thing, I was going to check if that is a perfect square by saying square root of 16. Obviously, for square root of 16, what is it? Is it 4 squared? Can you just confirm for me?
Yes, sir.
Okay. Then if it's a perfect squared, then you know you've got x squared 4 to the exponent x. Then already it means you've got this thing. You've got 4 and a 4. Then in terms of the signs, I just want us to confirm, guys. If it's a negative there, does it not mean we have opposite signs? And if it was a positive, then it's both positives. Can we just try to confirm that one? I'm not sure if that is true, but let's just check. I doubt it's true. Let me see. Let me do that and say, because according to what I'm saying, no, it won't be true. It won't be true. I'll just explain that shortly, guys. But I first need to prove that. So I was saying, because it's a positive there, then it means it's going to be positive. It won't be true because I'm going to have a middle term which is 8x. Then what about negatives? What about negative, negative? That times that, I'll still have a middle term which is negative. Yeah. No. It wouldn't work. So that means when it's a negative sign over there, in your brackets, you're just going to have opposite signs, just like you guys were saying, so that you don't have the middle term. So guys, did you understand what I was trying to check when we had a positive there? Were you following? Even though I was speaking to myself.
Yes, sir.
Yes.
Okay. So these are some of the things that you need to do when you are practicing alone, guys. Do this type of things to check if whatever that you are doing is going to give you something which makes sense. So now let me try to work out that one, because we said when you simplify fractions, can you see, Shreyas? You know very well
Yes,
that if
sir.
you don't see what is it, an equal sign, it's an expression. Cele, you know very well that if you see that over sign, you are able to see a numerator and a denominator, which means this is a fraction. So an instruction says simplify a fraction. Then you know when you simplify a fraction, firstly factorize numerator and denominator, or whichever that is possible to factorize. Let's follow that. So let's see, what is that at the top? So obviously we can factorize our numerator just like you did. You've got minus there. You can have a positive over there. At the bottom, wait, not 4, guys, but 2, isn't it?
Yes, sir.
Let me correct that and say 2. At the bottom, we've got x minus 2. Do you guys agree on that one?
Yes, sir.
Yes.
So, can we factorize this thing?
No, sir.
I know. So we cannot factorize. Let's see. We cannot factorize that denominator, but that at the top we factorized, isn't it?
Yes, sir.
Yes, sir.
So that means we can move to number 2, guys, which is cancel common terms to both numerator and denominator.
Yes,
so
sir.
what are we canceling, guys? What can we cancel?
So we can cancel the first x plus 2 and the denominator.
Give me the reason why you would cancel x plus 2 and that x minus 2.
No, sorry, sir. So you have to cancel out the terms that are common to both.
The common terms.
Yes, sir.
So the word that you are looking for is the common terms, ne?
Yes, sir.
Just hold it there. Cele, what are we
Yes, sir.
canceling here?
So you're canceling the the terms that are the same. Like at the top,
Which
you're
is
gonna x minus 2, and at the bottom x minus 2, and you'll be left with x plus 2, which will be your answer.
so Shreyas, I had to cut you there because I suspected you were also heading in the same direction. Can you confirm for me?
So what Cele said is true, sir.
100%. So now we all agree that we are going to cancel x minus 2 over x minus 2. Then we remain with x plus 2, which is the same as x plus 2, which is the end of that one. Can you see? So,
yes, sir.
So this one, this is how you solve for this one. So, Shreyas, I just want to quickly check something from what you sent, and then from there we are going to quickly do one type of a problem where we solve for what is it for x and y. So I also need to show you another type of a problem. So guys, the other thing that I wanted to indicate, Cele, in case, for example, if maybe you are now on chapter 9, in our case, even if we do chapter 2, which is what I've emphasized not so long ago, don't worry that much, guys. Trust me on that one. You will see, you will notice that once you are confident with the basics, you will never go wrong. And again, you will fully understand when they teach you guys. So quickly, Shreyas, what is that example that can you maybe check one of the examples that you sent via Telegram?
So I'm
I just
gonna
want
give you the first
to
one, which is 1D. 1D.
Oh, okay, yeah, 1D. Mm-hmm.
Which is 7x squared
Mm-hmm.
over 2y cubed
Over 2y cubed, yeah.
And then it's times
Mm-hmm.
3z over 5y.
You're saying 3z over 5y.
Yes, sir. And then it's divided by 14xz
Mm-hmm.
over 10y.
Over 10y. So
Yes.
remember, bod mass. Always when you simplify, always remember bod mass. So for this one, I won't solve it, but I just want to guide you in terms of where you start. And again, I'll have to start from the basics, because it's more like teaching you how to drive without firstly teaching you the rules for driving. I'm also not sure of what example I can use. So it means for me to be able to easily explain all of this, I'll need to first give you guys the basics, but I'll guide you in terms of where you can start this one. So between a multiplication sign and a division sign, you need to know which one comes first, which is a division sign over there, isn't it? So which means you might be having that as it is, and then you work out that part first, where you say that divided by that. Once you are done with that part, then you can multiply it with this part. Let's say maybe you had 2 over 4 multiplied by, let's say, a 3 over 6, let's say, divided by, let's say, what is it? 6, 9 divided by 12. So according to what I'm saying, I mean, firstly work out that part, because you need to sort out that division sign first, which means you might have 2 divided by 4 multiplied by. Is this thing the same, guys? Is it the same as 3 over 6 multiplied by, then I swap 12 over 9? Is that true, guys? Are you aware of that? Is that true?
Yes, sir. At school they taught us that way.
Shreyas, are you in agreement? Have they taught you?
Yes, sir.
Okay, I'm happy that we agree. So now, now that we have got all of that, let's just say because we started there, then we just first work out that one. Say 2 divided by 4 multiplied by. Then we can say, what is it? So is that multiplied by that, that multiplied by that? Or otherwise, you know, 6 goes 2 times into that one, and then this, what is it? It's 1/3. Or otherwise, if I explain it differently, I'm going to say 12 multiplied by 12. I mean 3 multiplied by 12. What is it? Is it 36? I think it's 36 divided by, what is 6 times 9? Let me, 6 times 9 is equals to 54. So can you see, which means even here, you might need to say, let's see, because it's 3z over 5y, then you'll multiply by 10y over 14x xz. Can you see? But in this case, because you've got letters, you might find that this cancels that. Remember, these are the common factors to both numerator and denominator. And then that cancels that. Then it means you remain with 3 multiplied by 10, which is 30. At the bottom, you've got 5 multiplied by, what is it, 14x. Remember, you also have that part over there, which is 7x squared over 2y to the exponent 3. So at the bottom, obviously, we've got 30. At the bottom, what are we having? What is 5 times 14? 5 times 14, it's equals to 70. Can you see? So now, there you've got 2x, you've got 1x at the bottom, which makes it a 1x at the top. And then you have 7 times 7, which, I mean, 7 times 30. 7 times 30. Don't worry, guys. I think this thing, I will still have to explain it to you nicely. But for now, I just want to check if the approach is the same. So that cancelled that. And this was 70. This was a 2 over there, which means 70 times 2 is equals to 140. Why? That remains as 3 because it never cancelled. So, guys, I just wanted to check if what I'm doing here, it's what you guys would also do, or if it's in line with what they taught you. I'm not sure if you are following, but here, guys, I was just talking to myself. Were you following, or you didn't see what I was trying to do or what I was doing?
So I was following, sir.
Cele?
I was also following, sir.
Okay, so Shreyas, we'll
Yes,
need
sir.
to firstly start from the basics on that one so that you fully understand all types of problems. But remember, at the same time, we jumped some stuff that we also need to do. So again, for the benefit of the both of you, Cele, what was that simultaneous? Can I write it quickly? What was it?
Okay, so let me check. It was 3x plus 2y equals 22. And 10x plus 2y equals 36.
Okay, so this is where you solve for x and y simultaneously. You remember, guys? You remember, most, was it yesterday's lesson?
Yes, sir.
Okay, so on yesterday's lesson, it was a bit different in a sense that you had to make y the subject of the formula in order to derive equation number 3. So here, obviously, that one is equation number 1, and this is equation number 2. So can you see, in this case, you've got common term on each equations. I'm not sure if you are able to see that common term, guys.
No, so we are able to see it, sir.
Which means in this case, you can use that method. What do you call? Is it elimination method or what is it?
There's 2 methods, sir.
Say again. What did you say?
There's 2 methods into solving.
So there's
the
2 methods.
Elimination method and the substitution method.
Yes. So in this case, because you've got common factor, you can use the elimination method. It is for that reason that you've got common factor, you can use the elimination method. But if you did not have a common factor, you could have used the substitution method, which is the method that we used or we did yesterday. So by looking at these 2 equations, you can see this one has got bigger values as compared to that one. So you can say equation 2 maybe subtract equation 1. So that means equation 2 first term is 10. Then you say 10 minus 3. It's equals to 7x. Then you say 2 minus 2. It's equals to 0. Where it's not necessary to write, then you can say 36 minus 22, which is what, guys? 36 minus 22, I'm getting 14. Then you solve for x. Shreyas, this is where I wanted you, just before we move to today's lesson. How, forgetting about all of this, Shreyas, what is this?
It's an equation.
Because of the equal sign. Obviously, we have to solve for the unknown, which is x, isn't it?
Yes, sir.
But how do we solve for x in this case?
So we have to see what gives us to minus our divide our 7 into our 14, sir.
Then, or maybe explain it to me. How do I solve this one? How do I write the next step?
Sir, can I just fetch my other book, sir, quickly?
Shreyas, don't go and fetch the book. You see, Cele, he's going to refer to that book, and I wanted him to just give it a try. Shreyas, are you still there?
Yes, sir.
So you went to fetch a weapon, isn't it?
No, sir.
Okay, no, it's fine. So give it a try. How do we solve for x there?
X. I'm not really sure, sir.
You're not sure, ne?
Yes, sir.
Cele, do you need 1 minute to quickly go and get a weapon?
I know how to do it.
Okay.
Yes, sir.
Okay, so Shreyas, I'm going to guide you on this one. Ne?
Yes, sir.
You remember when I said we've got different types of solving for x, which is what I wanted us to do after you knew how to solve this type of equations that have been given to you. When you solve for x in this case, you transpose, and then x is equals to 7 plus 2.
No, sir, I remember it now, sir.
This is 8. Okay, but now in this case, how do we solve for this one?
So you have your letters on your left and your numbers on your right. So which will be x equals to 7. 14, sir. 14 plus 7.
Oh, okay. Okay. 14 plus 7.
Yes, sir. Which 14
So,
plus 7 will give us 21.
Which is equals to 21. So does it mean 7 times 21, will it give us 14?
No, sir.
No, sir.
Okay, so Shreyas, that means we won't rush to that lesson where we multiply those fractions. I will still need to teach you how to solve all types of problems where you solve for either x or the unknown. So we won't move to that one until we are satisfied with everything. So that means even if you are preparing for your test that you'll be writing soon, we will still not be preparing for that lesson until you are able to solve this type of problems. Remember, you want to say x is equals to a number, isn't it?
Yes, sir.
But the problem is that 7. Can you see?
Yes, sir.
So that means you need to remove that 7. You remove by dividing by 7 so that it cancels and you remain with 1. Whatever you do on the left, you do on the right. So that means 14 divided by 7 is equals to 2. X is equals to 2. Can you see?
Yes, sir.
So you only transpose if you've got a sign of a plus or a minus. If you do not have this side, then you divide.
Yes, sir.
Remember, this is 7.
No, sir. Now, sir, since
It makes sense, ne?
getting back to me now, sir.
Yeah. So that means still, even if you remember, okay, no, I removed that by mistake. X is equals to 2. Even if you remember Shreyas, we'll still do it. Then I'm still going to combine them such that they look a bit tricky. Then from there, only after we'll follow that program until you understand. Because if we skip, then, for example, if we get to this type, then it becomes a bit of a challenge for you because you will still need to remember some of the information. And if myself and yourself, we haven't done it, then I'll just assume that you don't know anything about it at all, even if they taught you in class. But you might find that our teaching style are different, and mine maybe it's in connection with what we initially started with. But otherwise, I'm glad you remember. It means when we'll be doing it, you will quickly nail it. We won't spend much time on it. So now that our x value is equals to 2, it means we need to find the corresponding y value. So that means I think from one of these equations, you can choose one where you substitute that and solve for a y. Cele, is it not so? Can you guess on that? Am I correct or wrong?
Sir, can you repeat?
So I'm saying now that we know the x value is 2, for us to find y, we can use any of these two equations. Is it true?
Yes, sir.
Okay, let me choose number 1, which means we've got 3 into 2. Where I see x, I substitute that 2. So, Shreyas,
Yes, sir.
this is where I need you. I need you on this one. So that times that. What is that times that? Obviously, it's 6 plus 2y. It's equals to 22. So Now, Shreyas, do you think you can be able to try to solve that one?
So I'll give it a try, sir.
Okay, you can give it a try.
So since we have to have our numbers on the left, it will be y.
Mm-hmm.
We have to transpose both our 6 and our 2.
Then tell me what to write.
So it will be y, which equals to 22.
Mm-hmm.
22 is plus 6 minus 2.
Mm-hmm. Plus 6 minus 2, which is?
No, sir, it's actually which is 26, sir.
So the final answer, y is equals to 26, ne?
Yes, sir.
So Shreyas, it now confirms that we will still need to do more of this type of problems. So I'm going to show you this one. Then on tomorrow's lesson, we'll do more of those type of problems before we get to simultaneous. Then from there, we'll be doing simultaneous. Then we wrap up the solving for the unknown. So in this case, you transpose only 6 because 2y, there's no a sign of a plus or a minus in between 2y. So that means you only have 2y on this side, which is equals to 22. You transpose that, then it becomes minus 6, which is 2y is equals to, what is 16. This thing, guys? 16, what is it? Oh, okay. 16. So, Shreyas, how can we solve for y when we are at that stage?
Solve for y.
Yes, solve for y.
So same. So since we don't have any plus or minus, then we'll have to divide.
By
over 2, sir. 2.
100%. Which means y is equals to, is it 8?
8. Yes,
sir.
100%. So can you see, Shreyas, this is a problem that I was talking about when I said after giving you those type of problems where it's just maybe 4 minus y is equals to maybe 17. You remember, I've been giving you this type of problems which doesn't have a coefficient over there, where it's just maybe 3 plus x is equals to negative 9. It doesn't have a coefficient, it's just 1 over there, you remember? So
yes, sir.
The reason for that is because I wanted to start you there so that you do those easy ones where you understand you need to transpose the numbers, you remain with the letters. Then on our next lessons, I wanted to teach you this type where you've got a coefficient next to a letter. So do you now see that if we jump, then wherever we get to, it's going to be a problem because we haven't gone through this type of a problem. Can you see?
Yes, sir.
So would you agree with me that it's best to follow our program even though you are ahead of our lessons in class?
Yes, sir.
Okay, so it is for that purpose that if anything that I emphasize, guys, trust me, it's for the best. Even if you get, let's say you get 50% in your grade 10, you get 50% in your grade 11, whatever that I'm emphasizing here is what will help you to get distinctions in matric, because some of the information that you are learning, it only ends in grade 10. So in case if you are under pressure, maybe in school, you've got a lot of work and everything, then you can just do these lessons. We don't do any homeworks. Then we just proceed with our lessons until maybe you are done with your exams. Then from there, even during holidays, we can still have 30 minutes to an hour lessons so that we just refresh our minds and we we are up to date. So guys, this is what I wanted us to do for today as part of our simultaneous equation. So guys, this brings us to the end of our lesson for today. Cele, are you happy there with everything?
Yes, sir, 100%.
Shreyas, are you happy?
Yes, sir. Yes, I'm happy, sir.
Okay, so guys, I know you might be busy with your exam, so just take this time to prepare. I won't be giving you any homeworks until you are done. Ne?
Yes, sir.
Okay.